Welcome to Unit 1 of Class 11 Mathematics. In this unit, we'll begin our journey into sets and functions, one of the most fundamental topics in mathematics. Almost every branch of mathematics is built upon these ideas, making them essential not only for examinations but also for higher studies in science, engineering, computer science, and data analysis. In this lesson, we'll build an intuitive understanding of the first part of the unit and see how the topics are connected before exploring them in greater depth. This unit is organized into three closely related chapters. We begin with sets, where we learn how to describe and organize collections of objects. Next comes relations and functions, where we study how elements from one set are connected to elements of another. Finally, we'll explore trigonometric functions, where the concept of functions is applied to understand mathematical relationships involving angles and periodic behavior. As you progress through the unit, you'll notice that each chapter builds naturally on the previous one. Let's start with the foundation, sets. A set is defined as a well-defined collection of distinct objects. The term well-defined means that for any object, we can always decide clearly whether it belongs to the set or not. This precision is what makes sets such a powerful mathematical tool. There are two standard methods for representing a set. The first is the roster form, where all elements are listed individually inside curly braces. This representation is convenient when the set contains only a few elements. The second method is the set builder form. Instead of listing every element, we describe the rule that all elements satisfy. This approach is especially useful when working with large or infinite sets because it provides a concise mathematical description. Sets themselves may be finite, containing a limited number of elements, infinite, containing endlessly many elements, or even empty, meaning they contain no elements at all. Once we understand how sets are represented, we can study how different sets are related. A set B is called a subset of set A if every element of B is also an element of A. In other words, B lies completely inside A. Another important concept is the power set, which is simply the collection of every possible subset of a given set. If a set contains n elements, its power set always contains two subsets, making it an important concept in both mathematics and computer science. Now let's look at some basic operations on sets. The union of two sets combines all elements that belong to either set without repeating common elements. The intersection contains only those elements that are common to both sets. The complement consists of all elements in the universal set that are not part of the given set. These operations allow us to compare, combine, and analyze collections of objects, and they appear frequently in mathematics, probability, logic, databases, and computing. With this strong foundation, we're ready to move to the next chapter, relations. A relation describes how elements of one set are connected to elements of another. Every connection is represented as an ordered pair, where the position of each element is significant. To construct relations, we first form the Cartesian product, which contains every possible ordered pair between two sets. A relation is simply a selected subset of these ordered pairs based on a particular rule. A function is a special type of relation where every input maps to exactly one output. This single rule distinguishes functions from general relations. You can think of a function as a machine. Whatever valid input you provide, it always produces one unique output according to a fixed rule. While different inputs may produce the same output, a single input can never produce two different outputs. Every function has three important parts. The domain contains all valid input values, the codomain represents all possible outputs, and the range contains only those outputs that are actually produced. These concepts help us understand how functions behave and how different mappings are defined. Functions appear in many forms. Polynomial functions model smooth mathematical relationships. Rational functions involve ratios of polynomials. The modulus function gives the distance of a number from zero. The signum function identifies whether a number is positive, negative, or zero, and the greatest integer function rounds a value down to the nearest integer. Learning to recognize these functions and their graphs is an important part of this chapter. With functions understood, we move to the final chapter, trigonometry. Trigonometry studies the relationship between angles and functions such as sine and cosine. Before exploring these functions, it's important to understand how angles are measured. Angles can be expressed in degrees or radians, with radians being the standard unit used in higher mathematics. Some important conversions are 0 degrees equals 0 radians, 90 degrees equals pi by 2, 180 degrees equals pi, 270 degrees equals 3 pi by 2, and 360 degrees equals 2 pi. Angles measured in the counterclockwise direction are considered positive, while clockwise rotations are considered negative. These conventions become essential when studying graphs and periodic functions. The sine and cosine functions describe repeating patterns that appear throughout nature, science, and engineering. Along with these functions, we'll also study important trigonometric identities. One of the most fundamental identities is sine squared theta plus cosine squared theta equals 1, a relationship that remains true for every angle and forms the basis for solving many trigonometric problems. By now, the flow of this unit should be clear. We started with sets, which help us organize mathematical objects. We then studied relations, which describe connections between those objects. Those relations became functions, where each input has exactly one output. Finally, we applied functions to understand periodic behavior through trigonometry. This is why this unit is often called the grammar of mathematics. The ideas introduced here become the foundation for calculus, class 12 mathematics, and competitive exams like JEE and NEET. A strong understanding of this unit makes every topic that follows much easier. That completes our overview of Unit 1. In the upcoming lessons, we'll study each chapter in detail with examples, problem-solving techniques, and exam-oriented questions. Until then, keep learning, keep practicing, and when you're ready, test your understanding with a mock test or continue exploring with the academic co-pilot.